All right, friends, welcome to 2024. Wish you all a very happy new year. And I'm glad that we are continuing the trend that we started last year, which was trying to deliver at least one webinar each week on Thursday, which is like today, this time. So I'm assuming that some of you have attended our previous webinars and sessions and hope you've enjoyed, and that's why you have come back again. In the chat window, may I know how many of you have attended our sessions last year? So if I'm not wrong, we delivered maybe close to about 15 to 20 webinars in the later half of last year, 2023. How many of you attended? Yes. Do we have repeat audience? This is what I'm just trying to figure out. Okay. So for many of you, it's the first time and many of you are coming back again. Great. Great. Thanks. Oh, some of you attended in 2021 and 2020 and whatnot. Okay. That's good to know. Okay, great. Great, friends. Thanks for joining. My name is Amit Bansal and I work for SQL Maestros. And in SQL Maestros, I primarily do two things. First, I do a lot of performance tuning consulting engagements. So my consulting engagement is totally limited to performance tuning stuff. If SQL Server is running slow, if there are queries that are running slow, there are bottlenecks, I go and try to identify them and I try to tune the server, databases, SQL Server, and I try to tune the queries so that things run faster. That's what I do. And then all the learnings that I get from my real world projects, I bring them to my video courses, master classes, webinars like these, etc. So on sqlmaestros.com, you will find most of our work, which is the blogs, the videos, the free videos, the paid videos, the so-called membership. And of course, many of you might be aware of our YouTube channel, youtube.com/sqlmaestros, which is where you can watch a lot of free tutorials, and you can also join YouTube channel by paying a nominal fee and become a member to watch advanced videos. We have similar membership plan on sqlmaestros.com also. Apart from a lot of all this free stuff that I do, there are video courses and master classes. And just last week, not last week, sorry, last month in December 2023, we delivered our most popular performance tuning masterclass, which is very deep, 40 hours of deep dive content, which this was spread across 10 sessions, and each session was like 4.5 hours. It gives me immense pride, and I'm proud to tell you that we got excellent feedback, incredible feedback, because sometimes you do a lot of in-person classes which really go well. This was online and we had participants from more than 10 countries. So why not let me minimize this? And here is where I got feedback. So I wish to share this with you. There you go. And that is the link. That is the link for all of you from LinkedIn, where participants gave public feedback. And it's always good to get public feedback so that you could go and read stuff that is from real people on LinkedIn, etc. And just to let you know before I begin today's webinar, that this masterclass that was delivered last month in December was recorded. So the entire 40-hour delivery was recorded, and now the recordings are available. If you wish to access the recordings, of course, there is a price tag to it. But the most important thing is the recordings are available for a lifetime. So if you subscribe, it's not annual or biannual. Once you become a subscriber, you can access the content throughout your life. Watch as many times as you want, anywhere. This is the link. So if you go to this link, this is where one of my most very popular deep dive content, very popular performance tuning masterclass. We call it a SQL Server internals troubleshooting and performance tuning 40-hour program. So if you go to this page, you will see 3 masterclass recordings. These are the other ones. One is query tuning and optimization, 28 hours, and then a fast track version, which is 8 hours. But the one that I am talking about is SQL Server internals troubleshooting and performance tuning, 40 hours. If you subscribe to this, and just to show, if you click on start watching here, just to show you all, this is how the content is laid out. If you click on this here, and you will see session 0 all the way to session 1 to session 10, and you will see 14 modules. All right, friends. So this is where we are. Just wanted to make you aware of what we have been doing in the last few months. Okay, let's go back to the VM and let us get started with today's webinar content. You can save these links and say, explore all this stuff later. Okay, few housekeeping announcements for the webinar, for the content today. Feel free to ask questions. You can use the chat window or you can use the Q&A panel. In between, I will keep monitoring and answer the questions. Today's content is planned for about 40 to 60 minutes. Let's see how things go. And what's the topic today? The topic is query tuning, what really happened. And if you see on the screen, it says get contextual information. Now, most of my session, most of my content is about, okay, the query is running slow and we go inside the query and then we try to figure out from execution plan, from weight statistics, and a lot of these diagnostic techniques to figure out why the query was running slow. And then we try to figure out the bottleneck and tune the query. Now, the first step towards really is extracting relevant information. This is what I call as get contextual information about the query, about your workload. And really, a lot depends on what information is available to you. It's really like you working as a detective, trying to find out, okay, what went wrong, and you're looking for all the clues that are available to you. So I think if you are well equipped with a lot of information, with a lot of data metrics, and if that is available to you quickly and comprehensively, your life becomes a lot easier. So friends, today's session is not focused on me trying to show you a slow query and then try to tune it. I've done a lot of that. And on our YouTube channel, you will see so many examples and so many demonstrations around that. But today's session is actually focused on, okay, here is a query. What information is available after the query has completed execution? What kind of information I can find out? Common questions are coming in already, which is, will this webinar be recorded? Yes, all our webinars are recorded and they are available on sqlmaestros.com. Okay, so let's go and get started with today's content. So we will first use AdventureWorks 2016 here, turn on the actual execution plan. Let's do that. First things first, you're running a query. You want to find out the context of the session. Common things that I see, and this is all based on the real world experience that I had with our consulting projects. Trace flags are on. Some kind of trace flags are running in the session or globally that are affecting the workload that is running. It is having some kind of negative impact. So it is important for you to know that when a query ran, what were the trace flags that were on at that point in time. So let's run this query, select start from person.person, a very straightforward select statement. Let's go and execute this. Once I execute this and jump over to the execution plan and look into the select operator, right click and go to properties, you will see that there's no information available here about the trace flag, nothing at all, because there's no trace flag that is currently enabled in my VM in this environment. Now, what I'm going to do is I'm going to turn on this trace flag 101, whatever 101 is, just for the sake of demo, let's turn this on. Now let's go and run the query again. Now, if I jump over to the execution plan and select the select operator, now you will see that we have some information available here about the trace flag. So we have trace flags here. This is scope session and value 101. So that is the trace flag number. Now it says is compile time, which is false, which actually means is runtime, which is equal to true. This means that the trace flag was in effect during compile time as well as during runtime. So this information is important. So I'm just starting off from very basic, just like you have the session context, session information, all your set options. It's important for you to know which trace flags were in effect when the query ran. Okay, so let's turn this off. Just give me a second, friends. I'm going to switch on a light. Just one sec. All right, friends, sorry for the brief interruption. Okay, so this was a very quick one about the trace flag. Let's move forward. The next is about wait stats info. I think this is one of the most critical information that you may want to collect when your query is running, which is now this is here the typical thing about, when we do query tuning, performance tuning, I call what we call I use the term as proactive and reactive, and of course real time. So proactive is before the query ran, real time is when the query is running, and reactive is after the query has completed execution. Now real time troubleshooting here will be, let's say you have a slow running workload, and while the workload is running, you're trying to figure out what is going on inside SQL Server at that very moment. But then in most cases, the workloads are already gone, and then you get support tickets and you try to troubleshoot. And of course, you will try to reproduce the problem, which is you will take the report or the stored procedure or the query, try to run it again and try to figure out what is going on. So either way, when you do real-time troubleshooting, or when you're doing reactive stuff, which is after the workload has done, I mean, after you're doing the firefighting thing, you need to collect wait stats info. Now we are talking about wait statistics for your query. You're not talking about wait stats analysis for the entire instance. And this is one of the most critical things. Now I'll give you a very short example of this and how you can extract this information. So let's say we treat this window as connection one. This is user one. In user one, and this is user one, and in user two, which is connection two, we are going to begin a transaction, an update, a table called person.person, where last name, let's set it to Bansal, where business entity ID is equal to 1. So I'm going to take this, copy this in a new window. Let's create a new query window and paste it here. And let's go and execute this. Now, you know that this update statement has fired, and this is a in-flight transaction. So you have the starting of the trend, begin trend, but there is no commit or rollback. Now let's go back to our user one. We were treating this as user one. So here in connection one, I'm going to fire a select statement. Now you know that this is going to wait, and this is why I use the term wait types and wait stats. So let's go and execute this. And now this query is waiting. You know why it's waiting? Because it wants to acquire shared locks, and the other user is already holding exclusive lock. So this is waiting. Now you and I know that this is waiting because I did the scenario in front of you, which is created a blocking scenario. But think about the business user. The business user has absolutely no idea that this is a locking scenario, a blocking scenario. For the business user, it is as simple as, the query is not running, the report is not running, it is very slow, it has been more than 30 seconds and the query has not produced any output. So let's go and roll back this. So let's roll back, and the moment you roll back, this is going to complete its execution, and now the query is running and you get the data out. So what do you really want? You want wait stats info. So friends, from the execution plan, if I go to the execution plan here now and select the select operator, there is something here called as wait stats. This is super cool. If I expand wait stats here, it will give me a list of top 10 waits this query, this execution encountered. Remember, this is only for this select statement that we ran. Okay, so let's go and expand this, and then expand 1 and expand 2. And what is interesting, what is important for you here is the wait type LCKMS, and you can see it waited on LCKMS wait type. That was the class it registered for, and waited for 45 seconds. That's the wait time in milliseconds, which means our query was waiting on LCKMS because it wanted to acquire a shared lock. So this stands for lock mode shared. All right, so the questions are coming in. Can we use the same method to test in the production server? Of course, I mean, I'm just using SQL Server here, which is developer edition, and in your production, you will have enterprise edition and whatnot. So whatever I'm showing you here would run in any edition of SQL Server, obviously. Of course, some features that I'm showing you here might be in SQL Server 2017 or 19, etc. So yeah, I don't have a track of all of this is if there's something specific available in any specific version, that is something that you got to figure out. Okay, I'm looking into the Q&A panel. Let me do something, friends. Let me complete the demo and then I will come to your questions, right? Because there are a lot of small things that I intend to show and I want to make sure that I complete whatever I have planned. Okay, let's go back to the VM. Okay, and zoom out. Okay, so this according to me is very good. If this information was not available from the execution plan, I would probably had to set up extended events and collect information and then filter a lot of stuff based on only the things that I wish to capture. So at least if I take the query and run it in production, for example, suppose someone is giving me a store procedure or a report, I have the workload with me, I have the query, and I'm going to troubleshoot that query in isolation. I would just take that and run it in production, let it run for a few seconds, minutes, whatever it takes, and then just go and look at wait stats analysis by turning on actual execution plan. In fact, a lot of things that I'm showing you today are from the actual execution plan. And I'm amazed that over the last few versions of SQL Server, the execution plan information is so well enhanced and there's so much metrics available right from the execution plan. Okay, there's one more thing that I should show you, that because this is available from execution plan, there is a DMV also, which is not a bad DMV. It's good. Select star from sys.dm exec underscore session wait stats. Okay. This DMV, when I execute now, it will give me the wait stats data for this specific session, which is session ID 78. Okay, let's go and run this and let's see what we have. There you go. So here, wait stats, and we should actually order by wait time in milliseconds descending. Just to make this a little more meaningful, let's go and execute this. And you can clearly see LCKMS is right on the top there. So what's the difference between the execution plan stuff and what you're seeing here in the DMV? So the DMV, as the name says, session wait stats. Now in this session 78, I have been running a lot of queries and each query is waiting on something or the other. So the output from this DMV is an aggregation, cumulative wait stats info across all executions only for this session. That's why you can see a lot of them here. And of course, including this one that our specific execution encountered. But when I look at the execution plan of a specific query, then that is wait stats information only for that query, only for that execution. So I hope, friends, you are clear between what we saw in the execution plan versus what you're seeing in this DMV. Okay. Okay, friends. I hope the demos are going good for all of you. You're liking the stuff that you're seeing. Now let's move forward. So we were looking at trace. We are looking at wait stats info. Remember, the content here focuses on query tuning, what really happened. So after the query execution was done, we are trying to extract information from SQL Server so that we get all the right metrics, all the right information, and proceed with our investigation as to why the query was running slow. Okay, let's move forward. Parameter info. The next thing is, a lot of times you're running queries with parameters, be it stored procedures or be it just ad hoc queries with local variables. So let's take this example. So if we declare a variable here, last name, and we say varchar. So I'm calling this as last name and value is Duffy. Then I say select start from person.person where last name is equal to the local variable there. So let's go and execute this. Once you execute this, jump over to the execution plan. And again, I will go to the select operator and expand something here, what we call as the parameter list. So what you get here is parameter name and what's the data type and the length as defined. And you have the parameter runtime value. Now, this is very, very critical again, because when you are troubleshooting query issues, I'm sure all of you have come across parameter sniffing, or you have read about it, or you know about it. You might have encountered it, or you might have even solved it using a straightforward solution like option recompile. When your queries are suffering from parameter sniffing, it's very important to get the parameter information, the parameter values, what you see on the screen, so that you're able to troubleshoot and pinpoint exactly that this is a parameter sniffing issues. A lot changes with queries without parameters and with parameters. And of course, the stats that are based on that attribute, like last name, for example. So parameter information can also be extracted from the execution plan. So everything that I'm showing you in this graphical execution plan in the properties window, etc., is also available from the show plan version, the XML version, right? So if I right click and let's say show execution plan XML, this is where you get the XML, and you can always search on, let's say, parameter, right? And spelling mistake. So let's call parameter. And this is where you can see parameter list at the rate last name and the length and the data type and the value. So this is what we were looking from a graphical user interface. And this is what is also available from the XML. Okay, let's close this. Okay. The next thing that is important for me when I'm tuning queries is the stats usage. It's important to know which stats objects were used when the query ran. So let's say I run this query again. Now, without the parameter, I say where last name is equal to Duffy. So let's go and execute this. Now, either we have an index on last name, or at least last name is part of some index. And if it is part of some index, then there will be stats for that index. And if there were no indexes, at least SQL Server would have created automatic stats object on last name if auto create stats is on, which is default. So if I go over to the execution plan now, and again, select the select operator, I have another section here which says optimizer stats usage. So let's go and expand this. And you will observe that, yes, indeed, there is an index. There is an index, and that index, why I see that this is an index, just because I see the prefix IX. So you have an index which is a combination of last name, first name, and middle name. And there is an index, which means there is statistics behind this index. And you know, when you create indexes, you have the stats object that will have the same name as the index. So what you see here is the statistics object, which is being used. Now, what's most important here is the sampling percentage. Right from the execution plan, I can know that this was not 100% sampling. That's the first information. And I can also see that there is a modification count of 3249, which means that some data has changed and the index has not been updated, right? Sorry, stats has not been updated. So stats update is pending. Now, stats update, you know, there are certain criterias about 20% of data should be changing along, and then 500 rows, additional 500 rows, etc. So there are those thresholds. Now, only for the purpose of demo, what I'm going to do here is focus on modification count, which says 3249. And what I am going to do is now I'm going to begin transaction and update all the records to last name as Duffy. Okay, this is a trend because, of course, I wanted to roll this back. Let's go and do this. Now, when you do this, of course, a lot of data has changed. So, of course, more than 20% data has changed. We did a mass update, so all 100% data has changed, in fact. Now, if I go and do a select star from this table, let's go and do this. Of course, you will get all the records being returned because last name has been changed to Duffy for all of them. Now, let's go and look at optimizer stats usage. So if I expand this, now you will see that we use the stats. Look at the modification count now, which says 0 here. This means that now stats were updated. So after we fired the update statement and then we fired the select statement encountered that the modification count is much higher than the threshold. So it triggered a stats update, updated the stats object, and now the modification count is reset to 0. So these are critical things that you are able to figure out right from the execution plan. Now, if in case you're wondering, where does all this help? This helps in identifying cardinality estimation. So when you have actual number of rows and estimated number of rows, and there is a huge gap between them, this information is very, very useful, very, very helpful. So if you take the cursor over the arrow here, this is what I really mean, which is actual number of rows and estimated number of rows. In our case right now, everything looks all good because the stats were just updated. But when you have a huge gap, this is where you want to find out which stats were updated, what were the modification count, etc., etc. So the question I can quickly see on the screen is sampling percentage is still the same. What does it indicate? It indicates that SQL Server did not do a 100% sampling, which is when stats were being updated or created, it took a default percentage. It didn't take all the rows. A simple reason for that is when you have a table with a lot of data, SQL Server can decide to create stats or update stats with a default percentage. If it takes all the rows from the table, updating or creating statistics will just take a lot of time. So it takes a percentage for the purpose of sampling. Sometimes that sampling is good, sometimes not good. And when it's not good, you will see a huge gap in cardinality estimation. And then you go update stats with full sampling. Okay. Let's go and roll this back now. Okay. Now, the one thing that I really like about some improvements that were done to the execution plan is per operator performance tuning stats, which is for each operator that you see in the execution plan, like clustered index scan, the bookmark lookup, the seeking, the scanning, and everything. You get runtime counters per thread, right? That is one thing. You get actual time statistics, actual IO stats. That is very, very helpful because I don't have to really go and look into a lot of different DMVs and try to figure out that data. All that is just available on a click. See what I mean? So when I say select star from this table, order by line total descending, let's go and execute this. This query will run in parallel. I hope so. So let's go to the execution plan. And you can see that now SQL Server has chosen multi-threaded execution for this query. You can, how can you see that? You can always verify that using this icon, these yellow arrows and whatnot. These arrows, these are indicators that there are parallel operators. And what you see right now is parallel execution. What's really good here is if you take the cursor over clustered index scan, let's say, the kind of information that you get here is number of rows read. So you can see all the rows were read because we just did a select star. And if you expand this, you can see that there were 8 threads involved in running this query. And this is the distribution of data across all the 8 threads. So this is good. You can see this is parallel operation, how many threads were used and what was the data distribution. And not only this, you can also see the actual time statistics here and actual IO statistics. These two informations are equally important. So if you expand time statistics, let's go and do that. Look at this stuff now. So how much time each thread spent on CPU? So this was the total time, and how much time each thread spent overall. So this is CPU time, and this is the total elapsed time. That is something that you get on per thread basis. Now, if you're wondering how and when and where is all this useful, in parallel execution, when your query is broken down and the work is distributed to multiple threads, thread 2 could be stuck up somewhere. Thread 6 might be stuck up somewhere else. And you want to know how much time each thread has taken on CPU and what was the overall elapsed time for each thread. The overall query execution will be slow. That's why you're troubleshooting this query because it is running slow. But exactly which thread was problematic, where was it stuck up, what was this waiting on? So you want to find out, let's say, the wait information for a specific thread. So these things become very, very critical. So just like you have CPU time and elapsed time, you can also have IO statistics for this particular clustered index scan. So you had the logical reads, you had the read aheads, physical reads, all the information. So friends, you really don't need to turn on set statistics time on, set statistics IO on. All that is not required anymore. You can get all of this information from the execution plan. And one thing that I need to call out specifically, all this information that we are looking at right now is for the specific operator clustered index scan. This is only for this operator, which means if you want to find this information out for the entire execution, you can select the select operator and then you will get the time statistics. This is for the entire query, CPU time and the elapsed time. So the query, all threads combined, spent about 1.2 seconds on CPU and about 2.2 seconds was the total execution time of the query. So you are looking at time and IO statistics per operator. Very, very critical. Okay. Hope you are getting all this information, which is very, very useful. All right, let's move forward. Next is memory grant warning and memory grant details. This was a totally secret thing. This was a totally secret thing. And I can bet you, many of you who are attending this session today, this webinar, you will be like, wow, something like this can happen. And you were like, I'm totally unaware of this. And this is totally new to me. I would believe that things that I've showed you until now, you probably would have a fair bit of ideas, across different things, but this could turn out to be something totally new to you. Okay, let's see this. This is a select query where we're doing a cross apply and a multi-level sort, straightforward stuff. Let's go and execute this and see how much time this query takes. Let's go and execute this. Okay, and just wait for a few seconds. Okay, execution done. So if I show you on the status bar there, you will see that this execution took about 3 seconds. That's all, 3 seconds. And the execution was done. Now I'm going to do something interesting. I'm going to execute this again, but before I do that, I'm going to stress SQL Server with some workload. Okay, before I do that, let's jump over to the execution plan. And in the execution plan, this query took 3 seconds to execute. This could be a reasonable runtime for the query, and I'm sure you probably would be satisfied. Nothing much to investigate, but I will take and look at the select operator there. You will see that there's no warning on the select operator. Okay, important thing to note. Let's take the cursor over select operator and zoom in a bit to figure out that there was some kind of memory grant. Okay, all good. And you will see the statement, no warnings whatsoever. Everything went all well. But note that this query asked for extra memory. This is in KB, so this will be close to a GB. Let's call it as close to a GB. I know it's about 800 MB or something. So this is close to a GB, what this query had been asking for. It asked for that, it got it, the execution completed in 3 seconds, no warnings, no issues, everything is all good. Okay. Now, let's go and stress SQL Server. So I'm going to go to our masterclass content here, jump over to module 1. Let's go to common wait types and let's go the resource semaphore, jump over to demo 1. I'm going to stress SQL Server with some clients here. Back to Management Studio and run this query again. Now, when I run it, you will see that this query is going to probably take some time. Okay, now the output is not coming in 3 seconds. We're touching 10 seconds and the query is still running. So of course, something is not going good. Something is going bad. This is a very classic case of query performance issue. Query is running slow. Let's go and close all the workloads. Now, when you close all the workloads, this query execution will complete now. Done. Okay. Okay, let me ask the audience, what should you be doing now? This query took much longer than expected. Now it took 27 seconds. If you look at the status bar there, it took 27 seconds. Tell me in the chat window, what do you think, what you should be investigating and what was going on? Guesswork, or let me know what you wanted to investigate. If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on SQLmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to SQLmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.